The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our webinar today, where we'll be discussing IoT Edge and machine learning with Microsoft Azure. My name is Scott Seifman with Moxa, and I'll be your moderator. So today we actually have two presenters. Joining us from Microsoft is Chris Segura, the Senior Program Manager for the Azure IoT ecosystem. Chris is focused on helping partners deliver IoT solutions from hardware to cloud ISV. Today he'll be sharing a more in-depth view of what that all looks like. Alongside Chris, I want to welcome our own Robert Jackson, who is the Global IIoT Partner Program Manager. Robert brings over 15 years of experience in the industrial space in various roles. Currently, he's focused on developing an ecosystem of IIoT partners for Moxa. I really want to thank them both for joining us today. Before we get things started, I just have a quick announcement. If you have a question during the webinar, please submit it in the questions pane, and we can address them throughout the webinar or at the end during our live Q&A. With that said, I think we're ready. Let me hand things off to Chris to get us started. Chris?
Awesome. Thank you, Scott. Thanks, everyone, for joining us today. To get us started, I'm going to spend a little bit of time even just explaining at a very high level Azure IoT services, including IoT Edge. I think it's worthwhile for you to sort of understand our viewpoint and how all of these services fit together to complete a solution. And then I'm going to walk you through using machine learning, using intelligence, and putting that at the edge, putting that on devices, and walk you through a few scenarios that I think really highlight the advantage and use cases of intelligence at the edge. So let's go ahead and get started. I'm going to start here with a very high level, very simplistic view of an IoT solution. You may actually think, why are we starting here? This is way too high. I like to start at this level because it really helps sort of put a framework around where Azure, where Microsoft sees IoT solutions, how all of our services get built into these IoT solutions. And it's amazing how well this simple diagram applies to various industries. You know, recently I was talking to a partner of ours in the electronics industry. They were looking at advancing and sort of modernizing their manufacturing process. I was talking to them about how to use our Azure IoT services to do that, but when I started the conversation, I was giving them an example of us doing a very similar effort in the consumer packaged goods space. And the reason I started there is because everybody understands this particular product, everybody understood what we were doing. It didn't really matter at the end of the day whether the manufacturing process was a consumer packaged good or an electronics process. They all have process capability they wanted to manage and measure. They all had process optimizations they wanted to do. Everybody understood the first example, so when I reflected that to a more complicated example, it went very well. Now, it's easy enough to say that all IoT solutions fit into these buckets, but the reality is every IoT solution is a little bit complicated, is a little bit unique. A lot of the efforts we're working through with partners like Moxa are to help simplify and ease IoT so that partners don't have to reinvent the wheel every time. Partners don't have to start from scratch every time. So this is where we've been working quite a bit with the Moxa team. Later on in the presentation, you'll see some of the efforts we're doing together. Think of these three buckets as key buckets for everything I present later on in this deck. Everything is either part of the things, the insights, or the actions piece. To further highlight that, let me walk you through this next slide. This is a list of all of the platform services, various solutions you can get from Azure. Now, if you think of all of these boxes in these things, insights, and actions buckets, it's easy to understand exactly where various parts of the Azure services, whether they're IoT specific or IoT general services like Power BI fit. Now, for example, here on the bottom side, you see a list of various platform services, everything from Azure Sphere, which is a silicon solution, IoT Edge, which is a solution we're talking about today, and there's really more of a service. These are the things piece of the things, insights, and actions buckets that we were talking about earlier. The middle tier is some of the insights buckets. We don't have enough time today to talk about all of these in depth, but understand there are various insights you may want to gain in an application. For example, you may have hot path analysis. If you're not familiar with what hot path is, think of this as just looking at incoming data immediately as it comes in, understanding, is my machine operating the way I expect it to be? If it's not, we'll take action on that machine. Sometimes you have cold path analysis, the exact opposite, right? Sometimes I'm generating data that I don't need to look at immediately. I may look at 1 month later, one year later, right? So all of the various services fit into basically various options for you to control and optimize your solution. So you had the things on the left, you had the insights on the middle, you have actions on the right. These are all mix and match services that we work together with partners and with Moxa to help optimize your experience in using. There are, of course, other layers on top of this, layers where there is enough sort of commonality amongst requirements, commonality amongst situations and use cases where we can give you reference applications. We won't cover those in depth today, but just to make you aware, from Microsoft, there are lots of reference applications you can use as accelerators. You can get them online. All of the source code is available. Use them, tailor them, customize them to your need. And then finally, the highest level of abstraction is a service that Microsoft runs. We won't cover this at all in detail today, but realize there's these 3 levels from Microsoft runs the entire service to the bottom level where you build the entire service yourself. These are available for partners to use as appropriate to them, as appropriate to their solution. We work with Moxa and other partners in the industry to help sort of understand how all these are put together and simplify where appropriate your use of these services. And that's what we'll cover today, the use of IoT Edge in scenarios where machine learning makes a lot of sense. Now, before I get started on talking about machine learning, I want to hand this off to Robert, who's going to run you through our first audience poll. Robert?
Thank you, Chris. Really great introduction to Azure. We'd like to now talk to each one of you and kind of get an understanding of your application and what you're looking to do. So we'll bring up the poll briefly, and I'd like to know how many of you are considering deploying cloud-based monitoring solutions. Next, how many are looking to take advantage of machine learning? Or perhaps you're looking to do both cloud-based monitoring and machine learning together, or none of the above. If you take just a moment, we need you to actually select one of these options on your screen using your mouse. It'll be an interactive poll, and after just a few more time for the input, we'll go ahead and reveal what the audience results were. So again, first you could take a look at deploying cloud-based monitoring solutions. Are you considering taking advantage of machine learning? Are you looking at doing both cloud-based monitoring and machine learning, or none of the above? Okay, one last chance. Let's get those answers in, and I'll ask Scott to go ahead and bring up the results. Very interesting, kind of what I think we would expect. Almost 40% of you are focused first on cloud-based monitoring solutions, which is where we are also see a lot of opportunities today. Looks like 12% are taking advantage, but I think a really telling is 42% of you are looking to combine cloud-based monitoring and machine learning. So really take advantage of both those, and probably the most impressive of all is only 8% of you really aren't engaged in this area, at least at the cloud-based monitoring and machine learning. So really an engaged audience, which is great to see. And we're now going to kind of move forward and continue the discussion on how you can use Azure. And so with that, I'd like to bring Chris back to talk about an edge scenario in Azure IoT Edge.
Awesome. Thank you so much, Robert. I'm going to start here with this picture and use this picture to sort of illustrate a very common, very standard use case of machine learning, regardless of whether it runs at the edge or the cloud. But I'm going to use this use case in this scenario to talk about why you might want to pull machine learning out of the cloud and run it locally, make an intelligent edge device, basically. I think everybody understands the device in this picture, right? It's an oil well. The picture conveys a very common use or situation for oil wells where they're deployed in remote locations. This location might be hours away from the nearest city, maybe many plane flights away from the nearest spares depot. Wherever this oil well is actually located, whenever it gets turned on, people go away, people leave it, and it runs by itself. In 99% of the day, 99% of its life, that's just fine. It does what it needs to do. But that 1%, when the device starts to misbehave, when motors start to give out, when other issues start to arise, small issues suddenly can become catastrophic failures, right? And when you have a device like this that is many hours away, many plane flights away from a spares depot, when it breaks, if it breaks, it can be many weeks before you get it repaired. It can be many hours before even somebody understands it broke, much less being able to get out to the site itself and understand what the problem is. Now, this is a common scenario in oil and gas. This is a common scenario in manufacturing. This is even a common scenario in retail where devices may be deployed not necessarily far away from people, but in hard to reach locations. In all of these scenarios, what you want to do is have the device take telemetry, take data, understand its environment, but you want to look at that data, take insights, understand is the device behaving properly, and then ultimately take action on it when it's not behaving properly. Now, in this particular scenario, if the device is in a remote location, I can't count on internet connectivity. I may not have time to rely on internet latencies to take action. I might want to do action locally. This is where IoT Edge applies. This is where IoT Edge, the cloud, work together to take cloud-based machine learning models and push them and run the scoring algorithms, the evaluation algorithms at the edge. So let's walk you through an example of how that works, and then later on we'll actually walk you through a demo. So let me start here. This is sort of a classic example of IoT Edge and the cloud working together. You have the things piece by itself, sending information to the cloud, and the cloud generating insights and actions, right? And those actions can propagate all the way back down to the thing. This is a classic example. This is very much how you think about clouds and devices and IoT working today. But in the scenario we just showed you, I might want to actually run those insights and actions at the things level. I might want to push that intelligence to the device so that I don't have to guarantee that the internet is up before I can take action. I don't have to rely on low latency cloud scenarios to make sure I take action when the device starts having a small failure and preventing that from becoming a catastrophic failure. I might want to run those insights and actions locally. This is exactly where IoT Edge sits. Now, where IoT Edge plays is you have a device here on the left. The device is maybe an industrial gateway from partners like Moxa, where they are running IoT Edge. IoT Edge will help take your intelligence, your machine learning models, partner machine learning models, take actions on it, actions you define, actions other partners define, actions your customers require, and run those locally. Now, let me run you through kind of at an abstract layer how all of this works, how all of this actually takes place. So let's start here. You have a device collecting data from a machine. Maybe it's that oil well. Maybe in this example, that oil well also needs some protocol translation, right? Maybe this is an oil well that only understands a protocol like Modbus. Maybe this is an intelligent building that understands only BACnet. In any case, you need to translate that information into something more modern. You're going to take that information and monitor it in a machine model that you create, or maybe one of your partners create, and then you're going to take action on it like we talked about earlier. Now, the way you work together with an IoT Edge device is you'll have a device from a partner like Moxa that already has Edge pre-installed. You would use the cloud, or your partners would use the cloud to create machine learning models. Take all of the information you already have, create a model against it. Once you have those models created, then you can create things like containers. So you can take a model created, trained in the cloud, and containerize it. In this case, if you're not familiar with container technology, this is a Docker container. This is a technology that allows you to run these models cross applications, cross operating systems in isolation. The cloud will containerize your model for you. There's zero code involved in creating these containers. They get created for you once you create a model, once you create an action that you want. Those containers are then hosted in the cloud. In this example, you see them hosted in a container registry. This could be a registry you own. This can be a registry, like we'll talk later about the Azure module marketplace. This can even be something like the Docker registry. In any case, those containers get hosted in the registry. When you're ready to deploy, when you're ready to decide that that oil well has a certain set of features, maybe a protocol translator doing Modbus to something more modern, using a Azure Stream Analytics query to pick the right appropriate data set to put into your machine model. Once you have your model scoring, take action on it, you can define how all of that looks on a per device, per region, whatever granularity instance you want. You can then, wrong direction. You can then deploy a manifest from IoT Hub to your device that says, here's what I want running on this device. IoT Hub will talk automatically, no code written again. to a Moxa device that is running IoT Edge, says, here's the models I want to run, here's the modules I want to run, here's where to get them. Those will be pulled automatically. Nothing happens from a user perspective. This is all just in the background. Now, at this point, you've gone through the process of actually pulling information or pulling models and modules from the cloud and running them locally on your device. This is part of what IoT Edge is meant to do, sort of help orchestrate this process. IoT Edge also is involved in several other components, keeping the link up to the cloud up and running, but also most importantly, helping secure the device. Let's spend a little bit of time talking about security. Edge today offers 3 basic levels of a security promise. Think of this as a security promise as sort of a classification of devices, if you will. The first promise we call the standard promise is, think of these as legacy brownfield devices. These are the promise you can make on a device that was deployed last year, a device that was deployed 5 years ago, 10 years ago. The promise you can make on those devices is heavily tied to what the device itself was built with. In many cases, for example, older devices don't have anything like a TPM, don't have any concept of secure enclaves, secure environments. Edge can do as much as you can to secure the device. Maybe you can install or instantiate a software, firmware-based TPM on these devices. Edge will help simplify that process for you, but ultimately you're tied to whatever that brownfield device can support. Edge will work on these devices just fine. More modern devices, like the devices we work with Moxa together on, are devices that do start to support various levels of security. The middle level here is what we call the secure element promise. Think of these as devices that have some sort of TPM, HSM, can store secrets. This is a great level of security. This is a good bar to strive for today. But there is one more layer of security that is worth talking about, where IoT Edge and partners like Moxa, we work together to make sure there are solutions or will be solutions available in the market. These are solutions which have a secure enclave promise. Think of these as the superset of the middle device, where we have both a place to store secure secrets, but also a place to create and run sensitive logic, sensitive algorithms. Maybe you have a metering process that you don't want any customers, any unauthorized access, or any unauthorized parties. Maybe you have a place to run secure algorithms here, but you don't want these unauthorized parties to have access and be able to modify those algorithms. This is what a secure enclave gives you. It's a place to run sensitive logic in a cryptographically secure environment. We are working with Moxa on all of these levels. Robert will come back in just a little while to talk to you about some of our efforts in that space. Finally, just to kind of finish the high-level view of IoT Edge, let's talk about, where does IoT Edge sit? What type of devices are you likely to run IoT Edge on? You can see here a spectrum of devices, from the simplest sensor tier devices. Think of these as like Arduino type devices, devices that can't run an operating system, all the way to the sort of more complex tier, the gateway tier and above, where you have devices that have quite a bit of intelligence, devices that run Windows or Linux, devices that are ARM or Intel-based, 64-bit based devices. IoT Edge runs on these devices. It runs on Windows or Linux. Robert will talk to you more about some of the efforts we have together to get Edge running on Moxa devices there. In an ARM or x64-based environment, we run on top of these environments, and our job from an IoT Edge perspective is to help sort of orchestrate and manage the containers and modules we showed in the previous slide. These containers and modules are Mobi compatible based containers. If you're not familiar with Mobi, think of that as the open source underpinnings of Docker. Docker modules are compatible on Mobi. Mobi compatibles are compatible on Docker. We require sort of, or not require, but we work with Mobi compatible container runtimes. But again, for the most parts in this webinar, think of those as synonymous with Docker compatible. We'll talk later about security and HSMs. For the most part, when you think about what sort of workload you want to run on your device and how does that apply to machine learning, it really largely depends on what the workload is. If you are looking at a lot of cameras simultaneously, that's a heavy workload from a compute perspective. You want a fairly robust, fairly intelligent device. If your workload is largely just protocol translation, you can get by with simpler devices. All right, so that was an overview of the hardware requirements. Let's talk about where you can find that hardware. We have several Moxa devices, or we'll have several Moxa devices highlighted in our online catalog where you can sort through and find various devices. You see an example here of the UC8112. That catalog is constantly updated and will have several devices as they become Azure IoT Edge certified. We worked with Moxa to have one of the very first Edge certified devices. You can find that online today. There's the URL of where you find those devices. Finally, one last comment about Marketplace and our effort with Moxa. We are working with them to help deliver IoT Edge modules. We mentioned the modules earlier, like protocol translation. Moxa has a lot of great experience in protocol translation, a lot of industry knowledge, OT knowledge. They are bringing that knowledge to our Marketplace. Stay tuned for further information, further announcements from Moxa and Microsoft about what we're doing in that space. You can find all of that information, and if you're interested as well in creating your own modules, you can find information on how to get started there. So with that, this was a high-level overview of machine learning at the edge. I'll come back in just a little while to show you an example, but before that, I'll hand you off to Robert to talk about Edge Gateways. Robert?
Chris, thank you for the introduction to Azure and Azure IoT Edge. I also want to personally thank you for the great collaboration over the last few years as we've worked to integrate with Azure IoT Edge. Moxa is working closely with Microsoft to better integrate our industrial hardware expertise and specifically the Industrial IoT Edge Gateways with Azure. Today, we are very pleased to announce that the Moxa ARM Linux-based UC8112 is now available and certified in the marketplace with Azure IoT Edge, and also comes with Azure IoT Edge pre-installed from the Moxa factory. This is a key point. You can get hardware with Azure IoT Edge pre-installed. This allows end users to first benefit from integration with a leading cloud vendor like Azure, and then also more easily deploy and commission Edge gateways in the Azure Device Provisioning Service. To share a little more technical detail, this hardware comes with Azure IoT Edge pre-installed, and then as Chris has mentioned, through the use of containers, you can deploy Azure services like Azure Stream Analytics or Azure Machine Learning, and then also take advantage of Moxa's gateway management features to configure IP or cellular settings and access Modbus data. We're also working closely for more additional industrial protocols that will be available on the roadmap. And I'm also going to come back later and talk to you about hardware-based industrial protocols that are available today. This really is a collaboration between the convergence of OT and IT, and we're excited to be working closely with Microsoft. So let's go a little further and show you a real-world application. Today, our corporate headquarters in Orange County, California, has a solar system that we use to charge electric vehicles and generate power. We have taken this system, and over Modbus, we've connected that to a solar inverter. This is converting the data from the solar inverter into MQTT and Modbus through the Azure IoT Edge Gateway. We're also running some local analytics on the gateway with a Stream Analytics in Azure IoT Edge. Through MQTT, we publish this data to Azure IoT Hub, and then that resulting data is taken from a data lake in Microsoft Azure, and we've created a simple Power BI dashboard. We'll now bring up that dashboard and like to quickly show you live data coming directly from our headquarters. There you can see a picture. That's our headquarters in Orange County. You can see the current being generated is about 60. It's actually warmed up since earlier this morning at 68 degrees there in Orange County or Brea, California, and quite sunny. So we're generating a lot of solar power. My apologies for those of you guys in the Northeast. We are fortunate with the weather in Southern California. I want to also show you another key chart there on the bottom. You can see several weeks of total generated power. And what this is showing you is the flat lines are at nighttime when we're not generating power. And the constantly increasing lines are points during that curve in which we were generating power during the day. And so we can kind of keep track over time of how much power is being generated, but then we can also keep real-time statistics on the performance of this solar monitoring system. So it's just a great way to show real data from a real-world application and how the cloud and dashboards can generate visualization and analytics for you. So I'd like to go back to the slides, and we're going to talk a little bit more about the capabilities of the additional hardware that you could run in addition to this demo. So in addition to the UC8112 with Azure IoT Edge pre-installed, we also offer a wide range of industrial IoT Edge gateways. The ARM-based family offers smaller form factors for highly deployable solutions, and also variants with different Wi-Fi and cellular connectivity options. This year, we even released support for CAN and also some configurations with additional Ethernet ports. You'll continue to see more products in this family, and many of these products will come pre-installed with Azure IoT Edge as well. For applications like vision or machine learning that we're going to talk about next, however, we would often recommend an x86-based option, and we have those as well. Here we have x86-based options that today support Azure IoT Edge with Moxa Industrial Linux installed. We're also working closely with Microsoft to support Azure IoT Edge on Windows as well. Here, that could be useful for applications that might want to take advantage of SQL databases directly on the Edge Gateway, where Windows has a lot of built-in code that supports SQL quite well. Regardless, we've got a wide range of industrial IoT Edge gateways, many of them coming pre-installed with Azure IoT Edge over time. And with this new support for Azure and Azure IoT Edge, let's look forward at the new additional applications you can solve and start to address. And so with that, Chris, I'd like to have you share some of your approaches for machine learning with Azure and Azure IoT Edge.
Awesome. Thank you so much, Robert. Before I jump into the next part of our presentation, I want to talk a little bit about machine learning in general and just sort of help explain both the example I made before and the example we're about to walk in to now. If you're not super familiar with machine learning, that's okay. Think of this right now just basically as applied math. So for example, in the very first scenario, the very first picture I showed you where we had the oil well in a remote location, to do predictive maintenance against that, to monitor the incoming data, I'm effectively just doing forecasting. I'm creating a mathematical model that says, hey, my data tends to look like this. When my data stops looking like this, I take action on it, right? So in some cases, machine learning is just very simple forecasting applied and created into an algorithm that can run locally on a device. In other cases, I don't necessarily have forecasted information, but I might want to do classification. And that's the example we're going to walk into now. Classification is sort of highlighted by this example here. Here you see effectively a bunch of industrial pipes, right? This pipe is running oil, gas, doesn't really matter. There's not, in this particular case, a lot of telemetry you're getting from this. I might be able to monitor flow, that is one thing, but for the most part, what I might want to do in this scenario is inspect these devices or inspect these pipes and look for damage, right? Look for rust, look for holes. That is not telemetry data that you would create a forecast on, but it is a classification problem. And in both examples that we showed, the earlier example of where I'm just forecasting an incoming piece of data, or this example we're about to walk through where I'm doing some classification, the basic process is the same. I collect a lot of information. I create a model that helps me sort of analyze and interpret incoming data. And then based on that model, I score it against an algorithm. Now, the algorithms are very different between the first example and this example, but the process is the same. And it's the same process that you would run through using IoT Edge, combination of the cloud, and get these running on a device. Now, let me show you this classification problem running in real life. To do that first, I want to run you through just the high-level architecture of what you're about to see. Here you see a very simple version of what's running on either the oil well platform or the demo I'm about to show you. In this case, though, I am using a device. We call it a sensor here on the left-hand side, but think of this as just a camera, right? A device that is scanning those pipes I showed you in the previous slide, scanning faces, whatever it's looking for. It's capturing images, and that's it. Just capturing images and sending them off somewhere else. In the example we're going to run through, we have already pre-trained the data, so I already know what a general good pipe looks like. I have a lot of trained information. We created those in the cloud, created a module, put it into a Docker container, and pushed it to the device. This is basically what you see on this diagram as the module, the box that says AI. This is the device that takes that camera information and says, hey, this device or this frame looks fine, or hey, this frame looks like a problem. When it flags problems, you get a probability with that problem. Hey, this looks like fine with a 95% probability, or this looks like a problem with a 95% probability as well. It's just this one looks like a problem, the other one didn't. All of that, though, can be turned into alerts. All of those can be turned into alerts that are flagged on screen. You'll see that in the presentation or the demo in just a second. Flagged on a database somewhere, flagged in a dashboard inside the factory, right? All of these alerts are completely up to the solution developer and how they want to create this solution and how it runs. So let me show you a real life example of this, an example that we showed at the Build show earlier this year. So pardon me for just a second. Let me get the video running. Let me start the video. There's no audio in the video. I'll just go ahead and narrate above this. Here you see a drone, a simple drone. Apologize, the video seems to be slow just a little bit. All right, so we're all caught up. You see a drone being put on the floor here. This drone is a very simple drone. It doesn't have a lot of intelligence, basically a simple camera. The camera is taking pictures and sending them back to, in this example, a laptop, but think of this as one of the Moxa industrial devices, right? One of the devices that does have a rich operating system and a level of intelligence to analyze those images as they're coming in. So you see here the drone begins to fly. We'll fly over a building, we'll fly over a large field, right? The drone now starts taking pictures and streaming those in real time back to a gateway, back to an industrial gateway. You see here as we fly, all of the images are being analyzed right now. We don't see problems. Oh, here we do see a problem. Here we've taken action. You see on the right-hand side that yellow box that says anomaly. This is an example of just using machine learning on the edge to process information and highlight trouble, highlight problems. This drone is obviously too simple to take action, but that doesn't mean it can't notify people that action needs to be flagged and taken, and remediation steps need to be addressed. This was a very simple example, but I think an example that shows you how intelligence, how machine learning running at the edge can really help optimize scenarios from oil and gas to retail to manufacturing. Back to the first point I made at the beginning of the slide, all scenarios run into these things, insights and actions. Where you run the insights and actions is application dependent. In this case, you want it to run it at the edge because you want the edge to be able to flag things immediately, right? You may not have connectivity to the cloud all the time. You want the edge to take action and flag problems. So this is a very simple example of how to use machine learning, how to run it at the edge. I want to hand you back to Robert. He's going to walk you through a few other considerations you want to understand about gateways and running at the edge. So with that, let me hand you back to Robert. Robert.
Chris, thank you for sharing the exciting opportunity machine learning provides. I would now like to talk about some of the top challenges, or to be fair, customer questions we often hear when we're speaking with industrial customers and our distribution partners. Although we get many questions around this new technology, 4 common questions seem to always emerge. The first is, how do we enable edge connectivity to different protocols and sensors? The second is, where can we find rugged and supported hardware for harsh deployments? And then, of course, everyone wants to and should address security. And then finally, customers are asking, what are the architectures to best integrate with the cloud? Let's briefly discuss each one of these, and then after the webinar, we can share more additional detail and follow-up as interested. First, connecting to industrial data for most of our customers means connecting to a wide range of protocols. This is an area where Moxa has years of experience, in fact, over 30. Some of the IT customers want to know what software exists that can just simply connect to all the devices in the field or factory. We know simply connecting is really not true. This question really misses a core technical point. There are indeed protocols like Modbus TCP/IP that are based on standard Ethernet, and you can connect those with software. There's also OPC, which can abstract data or tags from hardware protocols. We support both of these options with our products and our industrial IoT Edge Gateways. However, for many industrial customers, they understand the value of hardware-based protocols. These are protocols like DeviceNet or Modbus Serial that uses a different physical connection, serial, rather than Ethernet, or protocols that have hardware timed. These are protocols like Ethernet IP and Profinet and they offer a lot of additional I/O timing and even motion control value and capabilities. For these cases, Moxa offers our industrial protocol gateways. These can be used to convert data to Ethernet, and then the Industrial IoT Edge Gateway can publish this to one of the cloud applications using publish-subscribe protocols like MQTT. So again, with a solution that's more distributed and more OT-centric, you can connect existing protocols to the cloud. It might just not be as simple as a single set of software solves all problems. For Moxa's industrial customers and partners, this is a familiar area we live. However, for many of our new IoT partners, this is an example of the industrial expertise and value that is unique to the OT market. To enable our customers to access and act on this data, we need to continue to work together to bring IT and OT together, and protocols are a great place to start. Another concern that many OT customers face is product longevity. In addition to rugged hardware design and long-term warranties, the software support is critical here for long-term longevity and support. We're excited to see Microsoft moving to support Linux. And now Moxa can offer our 10-year support with Moxa Industrial Linux based on Debian. The core Debian-based OS is still crucial in our applications and needed for industrial deployments. It offers increased boot speed, robust file systems, and enhanced security features to limit access to the Linux operating system. This brings us to the third common question, security. First, let me say security is an ongoing topic. As an example, we find that many customers' OT networks today can be made more secure by ensuring passwords are changed or updated, or that the right VPN and firewalls are set up. Although this is the responsibility of the operator, Moxa is working to offer tools that can survey a customer's network and offer guidance based on a green, yellow, red color code that meets IEC 62443 security levels. In addition, we understand how critical it is to secure end devices. And we believe Moxa was one of the first to deploy TPM 2.0 on an ARM-based Linux IoT Edge Gateway. This is available today, and we can share a white paper if you'd like to learn more. To connect back to Chris's point, this is really the secure element promise, or the middle bucket within his security architecture. We also know that customers and suppliers can't stop here. So without sharing too much of the roadmap details, this is one of the reasons we are working very closely with Microsoft on new technologies like Secure Enclave and the Secure Enclave promise, where you can have both a hardware secure module and the sensitive logic running inside of a secure element. If you'd like to know more about that, please reach out to us, and under NDA, we can share some of the progress. Finally, our customers often ask, what are the right architectures to connect their data to the cloud? One thing I've seen in industry is it seems many OT companies have multiple partnerships with many cloud and IoT companies. While this is great, the advice I give to customers is make sure there's more than just a marketing partnership program behind those claims. To lead by example, here at Moxa, we are focused on integrating our hardware and software architectures into the leading cloud vendors' platforms. Microsoft is a good example because our engineering teams are working directly with Microsoft to ensure that deeper integration provides real customer value. We selected Azure as the first to develop this deep integration with. We are also working with others. And for example, we're specifically working with leading SCADA providers like Inductive Automation to deliver Ignition Edge integration as well, which can really complement your Azure IoT Edge application. More of these integrations will come, and Moxa is focused on ensuring these integrations add value and are done at a more technical level. With that, I really appreciate everyone joining our webinar today. It's been great to see your perspective on deploying to both the monitoring and then machine learning. And so now we'd like to open it up to broader audience Q&A and panel discussion. And with that, I'm going to bring in Scott to moderate our panel discussion.
All right, thank you, Robert. And thanks to everyone who submitted some really great questions. By the way, there were a couple of similar questions that came in through the questions pane, so I just want to address that real quickly. So the question is this recording going to be posted on the Moxa's website? The answer is no, we're actually going to send this out. So anyone that registered for the webinar, you will receive a copy of this. So just look for an email from Moxa. So you'll receive that within 48 hours. Okay, as far as the questions for the webinar, looks like we have a handful. So we're going to dive right in. Looks like the first one, Chris, this looks like it's one for you. Is Azure IoT Edge available?
Yes, Azure IoT Edge is available. It went generally available, which for us is the equivalent of went to production earlier this year. In fact, we've already had a couple of updates since. So it is available. You can get it today on certified devices from Moxa, in fact.
Great, thank you, Chris. Second question, what industrial protocols are supported? Robert, you want to take this one?
Sure, thank you, Scott. So today in our Industrial IoT Edge Gateways, we support Modbus TCP/IP and OPC UA natively. But as I mentioned in my statement, you can extend this to hardware-based protocols as well. And using our industrial protocol gateways, you can support Ethernet IP, Profinet, and others in this line.
Thank you, Robert. Okay, the next question, Chris, what does Azure IoT Edge cost?
That's a good question. IoT Edge by itself is open source and free, but as we were sort of talking in one of the earlier slides, a complete end-to-end IoT solution is fairly complex, right? There are the modules we were talking about, which might run on the device itself. Those modules come from our partners. We enable our partners to monetize their module work however they see fit, whether they be open source and free or whether they be sort of like an application model where you get charged per module that runs on your device. Those are parts of a cost or the cost equation, of course. So you have to sort of understand what your scenario looks like and what modules you might want to use. Are they modules you create, modules you use from the store? That adds a little bit to the cost. And then there's a little bit of the cloud side, right, to understand from a cost perspective. Again, Edge by itself, completely free and open source. An entire solution, it just depends a little bit on what you're running and what the ultimate solution looks like. So it's a little bit of a complex to answer, even though it seems like it should be pretty straightforward.
Got it, thank you, Chris. Next question, looks like for you, Robert. How is the Microsoft Modbus module different than the Moxa Modbus module?
Sure, thanks, Scott. So yeah, at Moxa, we have supported and released Modbus and really targeted it for the industrial customer. So for example, with the industrial customer in mind, we support a GUI that allows you to configure the different Modbus registers and the tags that you want to associate with those. We also support analog tags, which requires you combining two different tags together to get all the analog rich data into your system. There is indeed a Microsoft Modbus module available. This is actually an open source module. And so one of the things Moxa has decided to do is that we plan to fully support and release software that's not based on open source for our industrial protocols. That's why we're spending a lot of time investing in Modbus and other protocols that are on the roadmap. So you can expect the kind of OT level of quality and OT level of support from the industrial protocols coming from us.
Great, thanks, Robert. Looks like there's a couple more questions that are coming in. So the next question is, can I deploy custom code to deploy customized complex business logic on edge devices?
I'll go ahead and take that one. The answer is absolutely. So to create an edge module, you use the Microsoft Device SDK. And in that SDK, we support 5 languages, C, C#, Node, Java, and Python. In those 5 languages, you can create any code you want. There are samples online that help you get started sort of like with a framework of what an edge module looks like. Those samples also include the tooling of how you take that module and get it containerized, if you will, get all of the base images wrapped up into a container and hosted in Azure Container Registry. Most of that, like I said, is already documented and online for you. The code you write is completely up to yourself. So yes.
Chris, this is Robert. Just a brief follow-up. You mentioned Node. Could you expand a little further on that for the audience?
Other than Node.js is the language we support.
Perfect. Thank you.
Yep.
All right. Thanks, Chris. Next question. Is the data available for public mining and analysis regarding the cloud and machine learning?
Ooh, tough question or complicated question to answer because I'm not quite sure what the context is. Mining in terms of using public data to create your own models? I guess it's
Maybe
hard
we could assume two questions. I think the first is if it's generally available in the public from the cloud, and I think the answer is no. And the second is, yeah, can you integrate public data?
Yes. So the answer, yes, exactly. And if that is the concept or the question, I'd agree with Robert's first comment. Is data available to the public? No. Can you use public data? Absolutely. Yep.
It looks like there's a follow-up question to that. How can I integrate the data?
From public to your own model, I guess, is the question. Lots of samples available online. It'd be a little difficult in this format to explain it. But if we want, we can follow up with some links to how you create and build your own machine model online. We could certainly follow up with those.
Scott, maybe if that audience member would like to give us specific information, we can follow up offline with focused answers.
Yep. Okay. Let's go with one last question. So what effect will this have on remote, hard to reach area where oil and gas pipes are installed without any cellular connection? So is there any satellite connection to bring the data to the IoT Edge in real time on Moxa hardware? Sure,
maybe I can answer that, Scott. So first, you are highlighting a very critical application that we've already seen a lot of success in, which is deploying to remote oil and gas applications. We've also even integrated and supported cellular for some large oil and gas companies for external deployment. On some of our hardware, the way that you do that specifically is through a PCMCA satellite card or satellite modem that's embedded. That brings up another point. The hardware that we're talking about here is really open. It supports Linux and Debian, so you can add other connectivity and other communication options, as well as your own custom code on top of Linux. And so for that example, satellite, I'd say, is not something we support natively, but we've had customers who've actually added satellite support for exactly that same application. And then I'll highlight also they've beefed up the storage available on the gateway so they can do more local storage and buffering. And that can be done either with Moxa or also with Azure IoT Edge. That can be done to provide that local buffering. So in case you don't have satellite, or if you just want to store data and decide after running some analytics what to send over satellite, it's all really core and part of the type of applications we're seeing and the problems that can be solved today.
And I might add a little bit to that. I loved your answer, Robert, on the hardware side, because that is where Edge doesn't really necessarily play, but it is part of the solution is how do you get the hardware talking to the cloud period or talking to a satellite link period. There's also things you can do at the software layer though, and we kind of touched on them at the very early part of the presentation. Some of the modules we were talking about, like an Azure Stream Analytics query or an Azure function, those modules can be built according to your logic to groom the data so that only relevant data goes to a satellite link, right? Satellite links are expensive, very low bandwidth. You don't want to stream every single message, or you probably don't want to stream every single message. IoT Edge gives you the flexibility to create your own grooming logic. So all of the information coming in, you look for relevant information, and maybe the only thing you wind up sending to the cloud is alerts, right? Or maybe you send alerts plus, I don't know, some key component, whatever it is. That's the flexibility of the platform that IoT Edge allows you to build. You can create that code yourself. You could create your own logic yourself, or you could use some of the first-party modules from Microsoft, like Azure Stream Analytics, to help sort of simplify the grooming process for you.
Great point, Chris. And to kind of bring it back, the demo that we showed everyone for solar monitoring, we're actually running Azure Stream Analytics to calculate the total net generated power on the edge device, rather than sending all the data and calculating it in the cloud.
Yes. Yeah, grooming can be a math function as well, not just eliminating data. Correct.
Great, guys. Appreciate that. I think that's a good stopping point. There's a couple questions left that we'll follow up with offline. So look for some emails from us. So anyway, that's it for the webinar. I want to thank again Chris and Robert for your time and sharing your expertise around IoT. If there's anyone that still has questions or needs help on an issue related to an IoT project, please feel free to reach out to us directly at usa@moxa.com. Also, you'll see a survey pop up after this broadcast. If you could take a few minutes to complete this, it really helps us improve our future webinars. Thanks again to everyone for joining us. Have a great rest of your day.